so here is part 3, last part of this. Bag contains 3 chocolate, 4 sugar, and 5 lemon cookies. Greg takes 2 cookies from the bag at random for a snack. Find the probability that Greg did not take 2 chocolate cookies from the bag. Explain why using the complement of the event of not choosing 2 chocolate chip cookies might be easier approach than an easier approach to solving this problem. So we're looking for the probability that he did not take chocolate chip cookies. So probability that it is not chocolate chip, which means that is the probability that it is, it is 1 minus the probability, is what I was trying to do. 1 minus the probability that it is chocolate chip cookies that he gets. So let's go find the probability of the chocolate chip cookies. So we've got 3 chocolate, 4 sugar, and 5 lemons. So that's 9 and 3, that's a total of 12. And so if I'm looking for the probability of 2 chocolate chip cookies, then that's going to be, let's see, how many would we have? 3 chocolates. So it's going to be 3 out of 12 times, because we've got 2 events going on here, 2 out of 11. So I can reduce before I multiply here. 3/12 becomes 1/4. And then this 2 can reduce with this 4. So in the end, what that gives me when I multiply is 1/22. So there's my probability of chocolate chip, 1/22. So probability of him not getting that when I come back over here is going to be 1 minus 1/22. And then that's going to give me probability of not chocolate chip is 1 minus 1/22 is going to be 21/22. At Kennedy Middle School, the probability that a student takes technology and Spanish is 0.087. The probability that a student takes technology is 0.68. What is the probability that a student takes Spanish given that the student is taking technology? All right, so probability that the student takes Spanish given that they take technology. So what we know here is that they take technology. We know that part. The way that they give me this information here, this is one of those where I'm going to have to use that formula. So this is going to be the probability of technology and Spanish over the probability of technology. So the probability that they take technology and Spanish is 0.087 over the probability that the student takes technology is 0.68. And so then I would just divide that out, and 0.087 divided by 0.68 is 0.13. I'm sorry, I can't read off the calculator. 0.2128. Oh my goodness. There we go. Okay. And then what is the probability of choosing the ace of spades from a standard deck of cards given that the card you draw is a black card? Okay, so conditional probability again. Probability that you draw an ace of spades, given that you drew a black card. Now, we could use the formula here, but let's think about what we know here. You know that it's a black card. Okay, there's 52 cards in a deck, right? If you know that you have drawn a black card, that narrows your sample space down to 26, because only half of them are black. So 26 cards is now what we can look at. And the ace of spades, there's only 1 ace of spades in the whole deck. So the probability of just drawing an ace of spades is 1 out of 52. But if you know that the card is black, now you're only talking about 26 cards, so your probability then is 1 out of 26. Don't need a formula or anything for that. Okay, number 20. A pet store contains 79 parakeets, including 35 that are light green and 42 that are female. 16 of the sky blue parakeets are male. Arrange this information in a 2-way table. All right, so back up. This is all about parakeets, male and female. We have 79 parakeets total, so that 79 goes right here. Then that includes 35 that are light green So my total for light green is 35 and 42 that are female. My total here is 42. 16 of the sky blue parakeets are male. So sky blue male is 16. Okay, so now that I have all of that, 79 minus 42 is 37, because these two have to add up to this. These two have to add up to 79, so 79 minus 35 is 44. These two numbers have to add up to 44, so 44 minus 16 is 28. And then to get this number, 42 minus 28 is 14, and 37 minus 16 is 21. Okay, so we randomly choose one parakeet. What's the probability that it is a female or sky blue parakeet? Okay, so my total female, so I'm looking for probability of female or sky blue. Right. So these are not mutually exclusive events because I can get one that's female and sky blue, so I can't do the two separate ones and add them. But I can look at my total for female is 42. So I'm going to use 42. And then to that, I can't just add the total sky blue because I've already counted these right here that are female and sky blue. So all I'm really adding are the male sky blue. So to this, I add 16, which is going to give me 58. So there's a total of 58 that would satisfy this right here. So I'm going to have 58 out of, and this is just randomly selected parakeet, out of 79. Right? And then that's it because it doesn't reduce. And you could do fraction, decimal, and percent, but we're not going to spend the time doing that. All right, what's the probability that a randomly chosen parakeet is both green and male? So we want the probability of green and male. So I look for green male, that's 21, and it's just randomly selected out of all of them, so that's going to give me 21 over 79. And once again, that does not reduce, and that's my answer. Then what is the probability that the randomly chosen parakeet is female given that it is green? Okay, so probability of female given that it is green. Now all this kind of notation is going to be important on the test. You've got to know how to write it and how to read it. And so this is conditional. I don't need the formula though. What we know is green. Okay, we know that it's a green parakeet, so we're only looking at this top row. So the probability that it is female and green, there are 14 green female parakeets. So it's 14, not out of the total, but out of the 35. Because remember, if it is conditional probability, your sample size changes, and this is my answer right here. Now, can I reduce this one? Yes, because these are both divisible by 7, so this is going to be 2/5. All right, so then last one. In a certain school, 19% play football, 65% of the boys, I should say 19% of the boys play baseball, and 28% of the boys play baseball and football. What percent of those that play baseball also play football? Okay, so this is conditional probability, but we got to be careful because it is the probability, it's not the probability of baseball given football. It says what percent of those that play baseball also play football. That means we know they play baseball, but then also play football. So we're looking for the probability of football given that they play baseball. Okay. And so this is another one of those that probably need to use this formula for it. So we're looking for the probability of baseball and football over the probability of baseball. Just because they give me 3 numbers doesn't mean I have to use them all. Probability that they play baseball and football, 28% play baseball and football, so 28% chance. So that's 0.28 up here. Over the probability that they play baseball, it's this right here, 65%, so this is going to be 0.65. And then when I divide those two things out, that gives me, let's see, 0.28 divided by 0.65. That gives me 0.431, which is a 43.1% chance. or 43.1% of them do. Okay. Make sure that you know your notation. I am going to give you the combination and permutation formulas as well as the conditional probability formula. Also look over your spherical geometry stuff, because I'll ask a question or two on that. I'm not going to go too in depth and try and make your brains hurt, but just see if you've been paying attention. Okay? So be ready and make sure you have your ISN and it is up to date. Those are easy grades.